Okay, I think we're live. Hopefully I'm live. If I'm not live, this is gonna be really awkward when I find out in like 10 minutes probably, but yeah. Hopefully everyone's doing alright today. This is day 99 of studying compilers every day until I land a compiler role. I am live? Okay, huge. I appreciate it. Okay. Yeah, so last time we tried to get started on tree tiling. I didn't really get that far, so we're gonna try to do a little bit more of that. I believe last time I did try to scribble some trees. Let me find where my graphic for that was. Open link. There we go. Okay. Yeah, so I scribbled this stuff out, and I very quickly realized I need to implement memory, or I need to like implement memory addresses somehow, and I'm not sure how to do that off the top of my head. So we'll have to get a little bit creative with that. Yeah, I have some ideas for how to do that, but there's a couple things I need to check as well. Just thinking ahead to when I'm gonna do like arrays, I'm trying to think what the best way to go about that is as well. I think I will just stick them on the stack, to be honest. Because malloc is gonna be really annoying to have to try and figure out a way to implement. So yeah, I guess I could just get straight into it. I think a good resource here will be the x86 cheat sheet. Yeah, there's these different memory addressing modes. I think this one might be, these two might be useful actually. Or I guess three, I highlighted three. All three of them will be useful. I think the absolute ones will be the least useful, at least for the short term. But I think the scaled and indexed one will be very useful because I'll be working a lot with like stack space. Yeah. So how does this work? So we have the immediate. We have we have a register. I guess I should like look this up properly. Or x86 memory addressing. Is this useful? Two addressing modes. Oh yeah, okay, that makes sense. I guess I will just have to make everything 64-bit, which is fine. Same size as each other, but don't have to be same as the processor mode. What? Okay. Okay. So this is the one that I care about here. This is very confusing. So we can kind of do any combination of these. So we have the scale, we have the index, we have the base, and we have the displacement. Displacement is just like pretty absolute, I think. And it looks like we can't actually do anything with it. Great, okay. Alright, that's a good start. The GNU assembler being called gas is so funny to me. Why would I use this? Interesting. I guess that makes sense. That could be useful. If I ever decide to implement global variables, I think, or I guess like static / global stuff, that could be useful. I'm not going to be doing that though, so that might make it a little bit less useful, but yeah. Let's see. Okay, base. So this is the, I guess the B register, right? Yeah, okay, that makes sense. Right, so the S is for scale, the I is for index, and then B is for base. I guess that makes sense. Well, I guess that means the immediate's not going to be very useful, unfortunately, but I think we could use, presumably we just stick the base pointer into this, so I think it's like RBP, I forgot which one it was. And then index we can pre-compute, which will be very nice. So yeah, looking forward to that one. What's good, dog at Carbonara? How'd you get started studying compilers? I began by taking a class here at my school. This is not like the answer anyone wants to hear, unfortunately, because I feel like that does leave a degree of like institutional barrier, but I think there's a lot of college courses on compilers that are recorded that are more than adequate. My recommendation, if this is something you want to do, I think there's 2 books I would recommend. The first is called Crafting Interpreters. It's pretty famous just for being just kind of a fun tutorial to follow along with. So I would suggest that one. And then the other one is called Writing a C Compiler. Yeah, you can look both of those up. I think those 2 will give you a pretty solid foundation to, I guess, build off of from there. Okay. So we don't care about displacement. Yeah, of course. Let me know if you have any other questions about anything. So we don't care about, so we have these 4. We don't care about displacement really. So base would be the interesting one here. Okay, so we can just load from a register, which is very nice. That's really funny. Store the immediate, so this into RBX. And then we can store, so RBX is now the address. So we can move into the memory that lives there. Okay, cool. That's nice. Calculated address, yeah. This is gonna be useful just for the base pointer, I think. Specifically base plus index will be, I think, the main addressing mode we use. We will have different syntax in this because we're doing AT&T, I think. My neck hurts from coding for the last few hours. Yeah, that, you've reminded me to worry about my posture as well. So, yeah. Quick posture check for everyone that is listening. If you're shrimped over, you should sit up straight. Yeah, back pain is not very enjoyable. But yeah, it happens. I imagine it's very easy to get locked in as well and just completely forget about posture. I know it happens to me, so yeah. Now LeetCode, I have not been doing LeetCode for a while, unfortunately. It's just not the top priority on my list of things to work on. Maybe I'll pick it up over the summer again, but at least for now, I'm a little bit more focused on just doing proper compiler work. Okay, this is useful. I guess what is... Oh, that's really funny. Hard time contriving example. Yeah, okay. So we quite care about we quite care about indexing into arrays. So this will be useful for that. Using my laptop as a screen, yeah, that one's a little rough. My setup when I didn't have a monitor was I have let me show this real quick. I have this little laptop stand. There's a lot of wires here, so yeah. I have a little laptop stand. I would put this on my desk, my laptop would be on top, and then I'd put my keyboard under here, and that helped a little bit. Not a lot, but just a little bit. Yeah. Myers just used laptop as well? Yeah, that's fair. What ended up happening with the job? I got an offer. For the purposes of the series, it's an internship, so I'm not gonna count it as completing the series. Mostly because I just want to stream more, but yeah. I have a compiler related internship for the summer. That'll be pretty fun. Okay. Base plus displacement. What is the difference? Is this just a... Huh. Structure, I see. Okay, that makes sense. So we have a fixed offset. That's interesting. I guess that makes sense as how that's generated. Congrats, thank you. Thank you all for the for the kind words. What's your favorite language? I think Rust has been the most enjoyable for me to write as of recent. Although I've liked Python, I found myself liking it less and less. I feel like the tooling is just a little bit less rich for it in my experience. And by tooling is less rich, I mean I can't figure out how to configure based Pywrite, so I just kind of have to deal with it. But yeah, I feel like Rust's tooling is very good. It just feels very fluid to write. I rarely find myself debugging it beyond just like, oops, I wrote my code wrong, in which case, like, fair enough. That will always happen with any language. But like, in terms of like language specific things, I feel like Rust has been very fluid. Okay, base index displacement. Yeah, that makes sense. So we can like do a struct and then like, or an array inside of a struct maybe. We have an array of struct foo. That's really funny. Internship? Yes. I have an internship this upcoming summer. It will be compiler related. That doesn't mean the series is over because I'm gonna like stretch the rules and say it needs to be like a full-time role. It's just like fun to stream as well, so I have a very strong disincentive to stop streaming at least. Okay, scale. This is gonna be the interesting one. 2 bits wide. 1, 2, 4, 8. I guess that makes sense. Array of pointers. Yeah, this is exactly what we want. Where is it? It's it's like a small local trading firm here in Chicago, roughly. I guess it'll be very public once I like make a LinkedIn post, but yeah, that is like the relevant portion that you would need to know. Okay, this seems to be the indexing that this seems to be the, I guess, memory structure we will be using for the most part. What's different here? Yeah, this is not what we will be using because we need a register. Now we're cooking with gas. Yeah, this makes sense. 2D array access, I guess that makes sense. RIP. The instruction pointer. That makes sense, I guess. Position independent code. Well, yeah, that makes sense. Segmentation. Okay. Okay, well, I think that's a good pile of addressing stuff. So all of these memory addressing modes are kind of just different flavors of this scaled index one. Like if you look at what's happening here, immediate only is just only the immediate and none of the stuff here. The register only is, I guess, only like the base with nothing else attached to it. So I think we can just implement memory just with this sort of model, and then I think we will be big chilling at least. Yeah, so let's do that. I think that will be a good goal for today. What's the plan for day 100? I thought about it a little bit. Unfortunately, I don't think I have anything special. I might say like a couple of like sappy words at the start, but beyond that, I don't think it will be particularly different from everything else. I thought about like buying party hats, but I mean, I decided against it for no particularly good reason. So yeah. Congrats on the progress. Thank you. Where did this opera end? That's where all this goes. Okay. Oh boy. This brings me joy. Okay. So we have registers, that's fine. So we have registers, virtual registers. We have immediates. So we want to define one more type under this. So this should be, let me bring this upwards a little. Let me zoom in a little. Yeah, so this is memory, I guess. This extends public operand. Anything else interesting here? Oh boy, this is not gonna be very enjoyable, I fear. Yeah, what do we even... Okay, so this needs 4 things. We need so it can take 2 registers, and then it can take 2 immediates, it looks like. S seems to be just an immediate. But it has to be constrained. It has to be 1, 2, 4, or 8. So we can kind of just like assume that that's true, to be honest. Okay, so we have that. How do we represent these? I guess we do register star. So this should be, or what are they called? Base. So we have base, index, scale, and displacement. So we have base register. We also want an index register. This should be lowercase. Yeah, so we have index. We want a scale, which should be an immediate, I think. We should also like have an assert in the constructor, I think. Yeah. So we want immediate star scale, and then we want immediate displacement, I think. Okay, that will do. And we'll figure out how to print this eventually. We might want like default values for some of these. Actually, no, we definitely shouldn't have default values. We should probably just null pointer the ones that aren't relevant, I guess. This also means this will not be very fun to print, but we'll figure that out as we go. Godbolt. I'm curious what the full print for the long one looks like with... Oh wait, there are Godbolt examples. Yeah, here. Because I'm using AT&T syntax. Alright, let's new tab that. Let's use AT&T syntax. That's what that looks like. Interesting. Oh wait, we can give it a register as well? Oh. That's nice. What is var? So, okay, I guess a lot of these are registers except for, I guess can be register, right? Okay. I guess we could just use like operand nested and call it a day. Okay, so index will, or scale will always be a, it will always be an immediate. So this one is fixed, but the rest of these I think can be just anything, to be honest. Yeah, let's look this up a little bit. Or actually, I wonder if ChatGPT can help me here. x86 addressing base, index, scale, and displacement. I believe scale can only be an immediate. Certain sizes. And the rest be immediate or register. Oh, okay. Interesting. Wait, that's interesting. So I see 3 registers here. So something is obviously very incorrect here. Interesting. Wait, what? Am I blind? This is the fun bit? Sort of. I am mostly trying to figure out addressing right now. I'm confused. What is... I don't understand. Oh, I see. Okay. So there's no displacement here. Interesting. Priority queue right now? And ooh. That one's always fun. I remember explaining heaps to people before with a deck of cards. It was really fun. Okay. So yeah. So I am just wrong here, luckily. So these are just registers, these are just immediates. So I think that's good. Okay. Let's make a constructor. Do I call this memory or just address, I guess? Address? I think address might actually be useful. I might actually just call this like... Yeah, maybe memory is reasonable. Do I call this memory or do I call this address? So we have a constructor there. We're gonna need getters for everything, which does not bring me joy, but I guess that's fair. Yeah, so let's go down here. Let's steal these. Get base. Get index. Okay. These all need to be functions. Okay. I think that's all good. We have all the getters we need. I guess, I don't know, memory seems like a fine name for this. I guess address? That actually makes more sense to me in my head, I feel like. So then we can also reuse this for other things. Yeah, because we load from the address, I guess. Okay. So let's implement this now real quick. I'm going to leave that on my right. Oh, I probably need to add this into operand manager. That's really annoying. Yeah, this is going to be really annoying to add here. Let's just, I guess, we can throw this into ChatGPT as well. How should I go about adding? Let's see what it says. It should not. Interesting. I should probably store them there, yeah. Yeah, okay. I mean, yeah, I guess what I could do is I could just make a store them and just always make a new one and no one would be the wiser. Yeah, I don't want to worry about this hashing stuff, so let's just keep a std vector of std unique footer. Vector is fine here because I'm just storing things. I do not particularly care about accessing them after this point. This will be where all the unique pointers live, at least. Yeah, so we have that. Addresses. Okay. And then we can just add address. Yeah, and then we can yank in here. There we go. That worked out quite nicely. Okay, so we need to implement everything in here, and then we need to implement this. This will be really funny, because we will kind of just like, this is kind of just a wrapper, but yeah, let's do that. So an operand, this should be the most simple one, I think. So an address star, not that. Paste that. We can get rid of this if, to be honest. So we want or we want pushback, I think. So we want addresses pushback. We need to make unique here. We do that. Base, index, scale, displacement. So we want, so we push it back and then we can just return addresses back. Oh wait. Get. There we go. That was quite smooth. so then, yeah, that one's fine. Let's, I guess, implement everything else real quick. Let's just paste all that down here. Yeah, this is very boilerplatey. Yeah, this is, yeah. Okay. Wonderful constructor. Yeah, we're gonna write this little snippet a couple times. Oh wait, the semicolon. There we go. Alright, I think everything's implemented, that means. So now we can use this to actually do things, I guess. Huh. What do we do now? I guess how are we supposed to do memory stuff? Actually, no, this is fine. Actually, this makes me wonder if I can still get away with like aggressively not worrying about aliasing. This also reminds me, I definitely need to change the way I do what's it called? I need to change the way I add allocates in tree generation, but I'll worry about that later. Let's commit some stuff real quick. Add addresses to operand. Okay. Just in case. Hopefully it all still works, but you never know. Hopefully this builds properly. Okay, perfect. Okay, so then... yeah, so we wanna look at tree tiling. I really don't like the way I'm doing this right now. I would like to do this differently, at least. Preferably in some way that doesn't rely on just infinitely dynamic casting things. So, yeah, hopefully there's another way to do this. I'm trying to think if there is. We could probably like, this goes back to the whole like serializing idea I had before. Yeah, this is very messy. I quite don't like it. I don't want to make a visitor again, though. A visitor would be very bad news. I might have to make a visitor though. I feel like that's the only way to like do dynamic dispatch without it being like terrible, at least. I wonder what ChatGPT says. Let's see what it does. Is there a better way to design this for Yeah, so that. Huh. Oh, that could be interesting. Huh. Yeah, this would be smart. I should definitely do that. Hmm. Huh. Hmm. Yeah, I might. I quite like that. Yeah, okay. We should probably bring back the visitor. Fuck. Okay. Um. Hmm. The DP solution seems really slow, so I really don't want to. I don't know. Let's look at more books, I guess. What's a good book for this? Does the Mushnik book mention it at all? Hopefully it does. If not, then like that's fine, but okay. Well, it doesn't look like it does. Um, maybe it's an IPA? I guess it's not. Okay. Well, everything else will be useful. Um, I don't want to look at the Cooper book again. I didn't find it useful for me. Yeah, maximal munch is, I think, the one that we care about. Make a new programming language? I could do that eventually. I'd need like a reason to at least. I don't think that's something I want to do if I like don't have a concrete, I guess, language design idea in mind. Maybe I could use these slides. Tax deduction. Yeah, this is like a good example of like what we could do. Yeah, I guess this is what we could do. I don't want to do this. So then, I guess what direction does... Oh, I see. So it goes in this direction. So I guess root downwards, which, fair enough. SIMD instructions. I don't want to do that. Like, I want to, but I don't want to yet. That'd be cool, though. Hmm. There's a bunch of sample rules here. I might copy some of these at least. That could be good. Yeah, I guess we could do the dynamic programming way, but that's scary. I don't want to do that. Sorry, gotta answer something real quick. I don't know what it is, but every time I try to type template, I type templates. Yeah, I feel that. Okay, well, I'm still quite lost on how I should implement this thing. I definitely do not like this though. I want to avoid dynamic cast as much as possible. How would I implement the tile patterns? Yeah, I think the tiles will also make this more scalable at least. Okay. Okay, that makes sense. Oh, interesting. Oh, I see. Yeah, okay, fair enough. Huh. I might actually implement this like that then. That seems very smart. So instead of a class, or instead of class, or Interesting. Okay. I should probably just do that. But that requires a lot of rewriting, and I'm not really up for that today. So I might like plan this out today, but I think that will put a ceiling on how much work I can do, at least for the time being. Yeah, so we're gonna need to simplify this, I fear, in some capacity. Yeah, this design really sucks. I should just do like a singular node, I think, with a type, and then like just like a children list, I think. Right? Yeah, because the only thing that's like not node in here, or I guess, alright, let's look through this. We have like maybe name here, or like value. How many lines of code so far? I could not tell you off the top of my head. I wonder if GitHub tells you that. Let's look at the repository. How many lines of code in a Git repo? Oh, that's cool. Yeah, that many lines of code. Clock? What is clock? Oh, that's cool. Okay. Good to know for the future. Yusuf, if you're sending a link, I think YouTube just blocks it. Yeah, this I want to keep polymorphism, but I think I will unfortunately have to leave this as is for the most part. How do I guess, would it be repetitive to just like store an enum with each of these though? The repo, where am I? Oh, interesting, okay. That's nice. Yeah, okay. I guess I could use that in the future. I don't think I'm very frequently going to be counting lines of code, but I guess I could do that. Do you use caffeine? None whatsoever. Yeah, okay. I think I will... I don't know. What do I even do here? It's gonna be really slow. So the problem right now is I can't really like match tiles without doing a lot of dynamic casting, and that will necessarily be very slow. So I'm thinking I keep an enum value in each node, which stores the type. And that will let us avoid all of the dynamic cast slush. That still seems like it'd suck. Because then that's kind of just like doing both things. Actually, no. I think that's pretty reasonable, actually. Yeah, okay. Okay, let's see what ChatGPT says about it, actually. Where was it yelling at me? I swear, there's something very bold somewhere. Keep polymorphism, but each node implements. You get type. Oh, okay. Yeah, wait. Yeah, sure. ChatGPT just glazed me. Yeah, sure. Okay. I think I'll implement that, and then I think I'll call the stream because I really do need to study for deep learning. My final is tomorrow, and I'm a little bit stressed about it. I'm not as stressed as I was like 2 hours ago, but I'm still quite stressed about it. So I should probably do that relatively quickly. Node type. So this is how do enum classes work again? Do I have one here? Or I have one in operand, right? Yeah. Okay. So it just looks like that. None register. I guess we could look through here again. Immediate. We should definitely add like a memory address type in here, I think. I'll do that. What are you working on right now? I'm working on instruction selection. So I have an optimizer language. I'm trying to turn that into assembly. They don't map one-to-one onto each other. And they don't like macro expand. So I need to do a little bit of shenanigans to generate, I guess, some degree of high quality code from it. So immediate. I'll add addresses as well, I think. Op. What else do we have? I don't know what to do with allocate. We'll just keep it for now. Store, and we have ASM. Okay, let's add a address type. Yeah, that makes sense. We can I think we should get rid of allocate then. Allocate doesn't make sense. Yeah, let's get rid of allocate node, and I will have to. Yeah, fuck it. We can drag out the stream a little bit actually. Let's get this done. So allocate node doesn't exist anymore. We need to create an address node. Actually, we could do a I don't know. What would that even look like though? Or I guess that's what the allocate node is, right? Or we need to. Oh, that would make sense actually, yeah. Sorry, let me read through the deep learning group chat. I need to like have to start studying. Well, okay. After reading that, I've decided studying is a little bit concerning. I'll worry about that later. Good luck on the final, on the sleep. Thank you for the support. Have a good one. Thanks for dropping by. Okay, let's get rid of the alloc stuff. We need an address node type. Oh, right. This doesn't exist anymore. Okay, how the hell do we make an address? I think. Fuck, okay. Okay. How do I want to represent this? Because I don't want to do like the whole addressing mode thing. I guess this could be like, I got like stack address or something, because we only have allocs for the most part. So it's not like we have like, we don't have like dynamically allocated memory in any capacity. So like nothing lives on the stack, at least here. Or nothing lives on the heap, sorry. I'm so lost. Okay. Maybe I should just like make an alloc. That might be smart. Okay, let's... I don't know what to give this. We definitely need something here. I could just do the 4 parts and it'd be fine. Ah, this sucks. This does suck though. I guess we have an operand manager, so we can just like... I guess for both of these, we can just kind of be lazy and just give it the actual value. And we don't need to like recode gen that, we can just steal the value from the node. That could be something we do. But then indirection, I don't know. I'll worry about this later. I'll throw a to-do here. And then just for good measure, let me update tree gen real quick for the alloc. We can steal this. This will be completely different. Where's an instance where I do something interesting with this? Yeah, I can just throw this here. We might also just not give it instructions. This might also just be like a virtual, I guess like some sort of a virtual add to the stack pointer. Actually, I might just do that real quick. Let's just ask, how should I translate optimizer IR allocs to assembly? Okay. So it should be static. It very much should be static. so this will go into the prologue, I guess, which is fine. Actually, no, this is perfect because all of our allocates are hoisted, right? So it should just like we should just be able to make the space. We should definitely make it virtual though, so we can like clean it up later. Add virtual allocate or virtual stack footer push. Yeah, I think that's a good start for now at least. If this builds, then I think that's a good place to, I guess, call it for today. Okay, looks like it builds. Make your own language. Yeah, I've got plans to do that. I just need like, I guess, a good reason to like make the language. But yeah, rest assured that is on the list. Okay, I'll test still pass. Yeah. More fumbling around with nodes and okay stuff. What's good, Mike King? I am unfortunately about to end stream, I think. Yeah, I have to study for a final that's tomorrow. So yeah, apologies about that. PC specs. I don't remember off the top of my head. Streaming tomorrow? Yes, I stream every day. Roughly, I usually stream around like 7 p.m. But we'll see what happens. But yeah, PC specs. I don't remember off the top of my head. Why not Linux? I have a Valorant addiction, so I can't really do anything about not switching off of Windows. I am on a PC. Actually, I could check Task Manager real quick. Let's see. I'm on a Ryzen 7600. And oh yeah, I have a RTX 4070 Super. That's all the relevant stuff at least. Anyway, yeah, I think I'm gonna call the stream here. I really do need to study. I'm getting quite antsy about it. Thank you all so much for tuning in today. Today was a little bit shorter and a little bit of an awkward time. If you're new here, make sure you sub to the channel. Make sure you like the stream as well. It gets my content out to more of you. Also in the description is my Discord. Yeah. You should join my Discord. It's the best place to get pinged when I go live, and also you get to chat with me and I guess the broader community. Everyone is really chill. Also down there is my LinkedIn and my GitHub. Yeah, feel free to add me on those if you're interested in, I guess, keeping up to date with what I'm doing. All right, work time. Why don't we stream Val? I suck at Valorant. Yeah, anyway, study time. Take care, y'all. Take it easy. Have a wonderful rest of your day wherever you are.